So we're going to now do R properly, in the sense that we're going to start looking at that script that I asked you to open at the beginning. So I'll actually move here. If you want to clear your console at any point, you can do Control L while you're sitting in the console, and that just makes it nice and clean. And you can also make it bigger or smaller. We're not so interested now in the console because we're going to be looking at the script. So we'll have this up and visible here. And what I've suggested here in the PowerPoint is the first thing you should do is to set your working directory. Otherwise, when you try and read things, or particularly when you try and write files, you don't know where they're going to end up. They could go anywhere. So you want to be sure that everything's in one place. And that's quite easy to do. You go up here to, when you're in R, you go to Session, Set Working Directory, and you can set it. I often set it just to source file location, which is where you've opened your current file, but you can choose anywhere with these menus. So, and then it will tell you where it is. In my case, it's in a folder I've got for Visual Aids Online Skills on my Dropbox. So there we go. So you should have been able to set your working directory so you know where you are. We're now going to go through the script almost line by line, and it will be doing very similar things to what you did on the console, but it will be doing it in a script so that we can then just sort of run it without typing stuff in again. But before you go further, I'm going to suggest that you install some packages. A package is like a set of commands or functions that R has that are specific to particular problems. So you typically will need particular packages for depending on what you want to do. I'll explain it all. There's a lot of explanation in this script with these hash signs. They are just instructions that it's a comment. It doesn't run anything, but it's there to notate your script. And so there we go. And I say first thing is to install packages. Quite often, if something doesn't work, it's because you haven't got the package installed, and it can sometimes that's a very common early error when you're doing R, that you can't understand why somebody else's script doesn't work, and it may be that you're just missing a crucial package. With more recent versions of R, it actually tells you, very helpful if you haven't got packages that you need. But these are all packages that you would need, and so if I wanted to install this one called MASS, you go to Tools, Install Packages, and then it should give you a menu. Yes, there we go. And I can say I want these three, MASS, HMISP, R with 3 R's. This is all case sensitive. And this may take a little while. We have had instances of the class where there has been some problems, particularly with YAR installing. If it doesn't install, we have other options. So rather than trying to get it to install, you can just ignore that for the moment. We use YAR later on, but there are other things you can do instead. And then if you just, once they're installed, if you type, if you just run those lines by highlighting them and typing run, not much happens. It just tells you it's loading them. It's loading a lot of things that are part of that package, not just the obvious names up here. We're not actually using these first two in the current exercises, but they'll come in on part 2. So I thought we might as well get them loaded up. I also recommend disabling scientific notation, because quite often it gets very frustrating when you've got this notation which is not, designed for situations when you don't want lots and lots of numbers, but you can't actually see what you're doing. So this is one way to do it. Option Site Pen will just disable that sort of notation. So you get very low p-values, for instance. You really want to be able to see them, not to have them rather masked. Right. Let's see what I'm saying here in my PowerPoint. Remind me not to miss anything. Yes, and so I've just done what we've said here. We run the lines of code you want to run. This one says plot new. I've taken that out actually. That's a command that no longer is really necessary, but we can check what's going on. The console will show you what's happening. And running a script line by line is a very good way to learn R. I learned most of what I know from doing that and inspecting what it outputs when you run a particular thing. Now we're going to start simulating. We'll run lines 56 to 68. So here we are, these lines down here. And again, I can make a bit more space here. So I've selected the number of values I want to simulate as and called it my n. So you don't see that in the console because it's assigned to this variable. You see it up here though in the environment panel. M1 is 0, my SD is 1. These of course are the default values, but it's sometimes useful to specify them explicitly if you may think you may want to depart from those defaults, which we will at some point. And then we've created that vector, and I've said, I've just typed its name, which allows you to view it. So here we have my vector, again, a whole load of random z-scores in effect. And I've also suggested we might want to look at the mean and the standard deviation of that vector. Yours will be, of course, different. And every time you run the script, unless we specify something to make it not change, it will be the same. And I point out here in that you're seeing things in the environment pane. Now, there's a question here that I've put. Your mean and standard deviation and my mean and standard deviation are not exactly 0 and 1, although up here I've put mean is 0 and standard deviation is 1. So this is a very key concept in simulation. Why are we not getting what we specified up here? Have a think about that, because it's important that you understand this particular point. It's not an error in the system, it's very much the system behaving as it should. So what I've said here in this slide is, in basic statistics, you will have learned differences between a population and a sample. So the mean and standard deviation that we're specifying determines the characteristics of the population from which we're sampling. So think of 1 million values that have got a mean of 0 and a standard deviation of 1. We're just pulling out 20 of those values at random. And so they're not going to have exactly the same values of what population that they come from. I then have a second question here. How would you modify the script to make these values closer to 0 and 1? Have a think about that. So the key point to bear in mind is that sample size is a major determinant of how close the sample you've pulled out will be to the population from which it's drawn. The more values you've pulled out, the more representative they'll be of the population, and the less likely it is that a value will be, that the mean will be influenced by one rogue value that's very high or low, for instance, if you've got lots and lots of them. So it's just sample size. You could modify, and you can, I'm going to suggest later again that you play with the script and see this in practice, but you can see how the sample size affects the values you get. We'll then run another set of lines to generate data for another group with a different mean this time. So here we've got a mean of 0.5. So same standard deviation. So you've just shunted along the values to give the mean is higher, and we can run those lines. And as you can see, the mean of vector B is indeed higher than, sorry, the mean is 0.20, the standard deviation is close to 1. So it's not, again, it's not 0.5 actually when you've drawn a sample, although it's drawn from a population that has a mean of 0.5. I've also noted here in the script that you can use a command called set seed, which will ensure you'd always get the same values when you run this. But of course, if you're doing lots of different simulations, you don't always want to get the same values. You want it to change with each run. But I've put a little note there, you can certainly check that out. There's situations sometimes when you want to have reproducible data. And then if you want to compare your two vectors with a t-test, this is what we did on the console. We can just run that line, and there you have the t-value. In practice, when we're simulating data, it's not essential, but it's often very useful to put data into a data frame. So it looks then more like the sort of worksheet that you have in Excel. It's a way of storing the data where you can have observations in rows and variables in columns, although in fact there's different formats you can have where you might not want to do that, but for the moment we're going to treat it just like our Excel data frame. A thing about a data frame is it can hold things other than numbers. It can also have factors and string variables. So we'll put our newly created vectors into a data frame, and we'll have a column for group and a column for score. And so in an earlier version of the script, I had a rather clunkier way of doing this, but this is a fairly simple way to do it. What we're doing here is we're just bolting together with this concatenate thing, my vector A and my vector B. And we're just assigning that to a data frame with that data frame command. So you see now we've got a data frame called mydf, and you can inspect it by just clicking on there, and there it is. So that's not yet got the group, but it's got the score. Go back to our simulation, and we give it a sensible name for that column, which now we can see is called score, rather than that long thing that it assigned it. Now we want to add group, and we just want the first half of the numbers to be group 1 and the second half to be group 2. The easiest way to do that is to just give everybody group 2 to start with as a default. And notice it didn't have to define group separately. We can just say we want to create a data frame column called group and give it the value of 2, and then we reassign the first lot to value 1, just the values 1 to my n. And now when we look at mydf, you can see as well as the score, we've got group, and it's 1 for the first half and 2 for the second half. And the beauty of doing this in R this way is that if we change my n to 1,000 or 5,000, this would still work. So you just have everything defined. Not hard coding is when you put absolute numbers in there when you're doing these computations. And it's usually a bad idea to do hard coding of anything because it makes it inflexible, and it's easy to then get errors when you forget to update things. Okay, so we've now got our data frame. Let's see what we're going to do next. And one reason for making a data frame is that a lot of functions in R operate on data frames, and one of them is this nice little plot that we want to do from the YAR package. Creates a pirate plot. So first of all, we're going to do the t-test again. This time we're going to assign it to a variable, so we don't see the results of the t-test in the console because they're saved in myt. But if we want to look at it, we'll see it's all there. The beauty is that this whole set of information stored in myt, you can access any bit of it that you want. And if I want the p-value, I can go myt, and it then, when I put that $sign, it throws up all the things that I might want to look at. And I think I might want the p-value, so I go there. And I just get the p-value out. So we're going to use that ability to take a little bit of the output of the t-test just to create a nice little header for the graph that we produce that gives you the t result and the p-value. And so down here, we're going to go on to the header. Paste naught is a little command that allows you to glue together bits of text. It's quite useful when making headers, and naught means it doesn't insert any blank spaces. So we're just going to make a header that has the words t equals and then the result of the t-test, which is the statistic from here, with a semicolon and then the p-value. So if I run that, you can then see my header on that line, see what it's created. It's created a header that has the t-value to 2 decimal places and the p-value to 3 decimal places. And then we're going to do this rather exciting thing called a pirate plot. And let's see what happens when we do that. It's a bit squashed together. You might want to see it better here. So our header is at the head, this header, and it plots the whole distribution of scores for group 1 and group 2. And what's nice about the pirate plot is it shows you the shape of the distribution. It shows you the median here, and I think that's the interquartile range, and then the different values of the Z-score. So you get a much fuller picture of all the data when you do that. It's not a very well-known type of graphic, but it's good to Google and look at it and see what all these, it's got, again, many ways you can modify it. You can change the colors, you can change exactly what it represents. And it's, again, the thing to do is to learn R by fiddling with commands like that. So general points to help you learn R. The basic rule for life, especially when programming, is if you don't know it, Google it. And if you get an error message, they're often completely cryptic. You have no idea what they mean. But if you Google it, somebody else would have had the problem and it will hopefully be explained. And I keep saying best way to learn is by making mistakes, because a lot of people get terribly discouraged when they try and run things and it doesn't work and they can't work out why. And you will inevitably go through periods where you're banging your head against the wall because you can't work out why something isn't working. But you just realize that then you really remember it when you get it right, because you spent such a lot of energy trying to get it to work. Always check your environment tab to see what's going on when you're running a bit of script. Try running bits of script one line at a time where possible. Type the name of the variable on the console to check what it is. Is it what you think it should be? And then I often am very unsure about functions. So, I mean, there's a function to create repeated values. And I can never remember whether it's rep 1, 3 or rep 3, 1 if I want, for example, 3 copies of number 1 or 1 copy of number 3 or whatever. And so you just type it on the console, try it one way, try it another way until you know, until it works, and then you find it out. So you have to be quite experimental. So what I suggest you do now is to explore the simulation. I would say this is a very key part of this course. If you get to this point and you feel reasonably confident, I think I'd keep trying until you feel reasonably confident that you know how this simulation works, what it's doing, and can see some point to it. But what you should then find is that if you run the script several times, you'll see the so-called dance of the p-values. You'll see that the p-values change a great deal from one run to the next, particularly if you've got a small n. And you can save the script under a new name and then play around with it without worrying about losing the original. And you can try varying the sample size or the values of the means, or indeed the standard deviations. You can vary whatever you like. If you set the two means to be the same, how often do you get a significant p-value? Try these things out. Make a note if you have questions that you want to discuss or things that are unclear. Because we'll have an opportunity to feedback those sorts of things after you've been through the lectures. But I'll finish there.